Hello, so today we will have our second lecture from electricity and magnetism, and the last lecture I left you with this representation of electron flow, and I told you that battery is producing an external electric field, so producing producing electric field in the wire, and these homeless electrons in the wire, they are moving. So at each this particular point, this point, so at each particular point in the wire, this thing is happening. There is external electric field and electrons are moving to this direction from minus to plus. At first electrons of the wire electrons are moving, and then electrons are going from this terminal, and the electrons in the end reach this terminal. And you know, because when electrons leave this terminal negative, this terminal is becoming neutral, and this terminal also is becoming neutral because electrons combine with this plus. So therefore, in order to keep this terminal positive and this negative, internal chemical reactions in the battery have to redistribute the charge, have to take electrons from this part and put it here, so that this terminal would be positive and this terminal would be negative, and the current would flow constantly. So now I will try to explain you what electric potential and voltage is. It's a bit difficult to understand, but we may try to understand it in the way that potential is potential energy. So we will try to understand like this. So every object changes its state. We can say travels from higher potential energy to lower potential energy. As you remember, we had a box lifted above the ground, and at the height, some kind of height, and this box was pulled down by gravitational force. F is equal mg, because this box was in external force field, so gravity force field of gravity, Earth's gravity, so it has potential energy. So potential energy was EP, was force times height, h, and it was equal because force is mg, so it was mgh. And when the box falls down, when it is falling down, what's happening? Potential energy is turning to kinetic energy, and kinetic energy is turning to work. So it means that this box hits the ground and breaks the surface. So at this state here, this is potential energy is max because it's maximum height. At this state, potential energy is 0 because height is 0 and height is here. Multiply by 0, 0 multiplied by max, we'll get max. So potential energy max, potential energy 0. Every object is falling down because potential energy is higher than here, and by going from state EP high to EP low, it produces work. So produces work. From high to low produces work. Potential energy, of course, turns to kinetic energy, and kinetic energy produces work, like we said here. So I wasn't lying about that. So imagine we have two parallel plates. We have plus is here, minus is here, and we have small positive charge that is moving into this direction. So this small positive charge, what is going on with it? It is moving. So this charge travels in E field due to what? Due to Coulomb force. So this Coulomb force is electric field times the magnitude of this charge. So because it is affected by force makes him go here, the same as the box was due to Earth's gravitation. So it goes the distance the distance we may call it, we may call this distance, let's say it goes the distance from here to here. We may call this distance delta D. So it goes this distance, and charge goes from higher potential energy, you can call it EP1, to lower potential energy, we can call it EP2. So now we may this would be this distance would be D1, this, and this small distance would be D2. So the difference between distances is delta D. So charge goes from EP1 to EP2. So it has potential energy, and this potential energy is how it is provided. It is provided by force times distance. Force times distance, as it was force times height. Remember, force times height. It was force times height. So here it is force times distance. The same. Imagine if we turn this, and this was falling down. It would be exactly the same. But in this case, it is just electric forces. So because charge goes from EP1 to EP2, one potential energy state higher, this one is higher, because D1 is higher, yes, longer. Work is done. So this charge has speed, it has kinetic energy, so potential energy turns to kinetic energy, and also this kinetic energy can be turned to work. This discharge may push something, yes? So work is done, so we write work EP1 minus EP2. Or we can write in terms of forces, that force and distance, FD1 minus FD2. And it is, then we can write that it is FD1 minus D2. So D1 minus D2 would be, if we write F minus D2 minus D1, and F times minus delta D, and because delta is changes, it would be D2 minus D1. From the position number 2 we subtract position number 1, so it would be minus F times delta D. So follow this step and this step. This is intermediate. Okay, so work was done. So voltage is the work, or we say potential energy, that electric charge does by traveling the distance delta D in this external electric field that is produced by battery. So this is what's happening here. So now we will write, so the work, here again, work is EP1 minus EP2, difference in potential energy. And now if we, so this work is done by this positive charge. Okay, positive charge. So let's divide this work by Q, and let's divide also this part by Q, and we can write that it would be phi 1, phi 2. This would be phi 1, this would be phi 2. And this is voltage. This is voltage, U, potential difference. Potential difference. So voltage is potential difference, and potential is what? Potential is potential energy per unit charge, because it is divided by the amount of charge. So this is what voltage and potential is. So now if we it's phi 1 minus V2, sometimes voltage is written like minus phi 2, phi 1 minus delta phi, because it's reversed again like here, because change is because delta x would be x2 minus x1. If we want to write x1 minus x2, we write minus delta x. So the same thing is going here. And now if we multiply the amount of charge by voltage, this is provided by the battery, voltage of the battery, we know the total work that this amount of charge did while traveling in electric field. So it means that work, so the equation would be work is equal to U times Q. So here work, Q and U. See, this is where it comes from. Now what's two things. One thing is that work is minus F times delta D. It's okay, so everything is okay, but minus F times delta D, and now divide by Q, by charge. What do we get? Work divided by Q is U, it is voltage. What is this thing? This is E, so minus E times delta D. So it means that voltage is minus E times delta D. So it means how it can be calculated from electric field. Now since voltage is potential energy and divided by charge, so the units for voltage are joules per coulomb or volts. Joules per coulomb, energy per unit charge. So potential energy per unit charge, energy charge. So this is what we say voltage. So voltage is work or potential energy for unit charge that it releases while traveling in electric field of the battery. See, all this, we can write this down and study. I know it's difficult to understand, but it's possible, because this time I wasn't so messy in writing this thing like I usually am. So this we can keep. Now what else I want to tell you? I'll just check my notes. Now the next thing is resistance. So resistance. Imagine that it is a wire, and there are metal wire, of course, and there are atoms having plus charge, and this charge is balanced by electrons. It's not appropriate to call those atoms nuclei, but electrons are, because electrons are there, but just those electrons just they are moving, homeless electrons. But now imagine one electron that is coming, that is moving, because there is electric field in the wire. So let's say we can write lines, draw the lines that, but imagine that those lines are, an electron comes and it hits this atom, hits and it collides with that atom, and just it goes back because it is pushed away. Then it moves again and hits this atom. It's pushed again. Then it moves, hits this atom, pushed back. Then it moves. Then it hits, let's say, a different atom and is pushed back, collides with it and pushed back, and then it goes again. So what you see, this electron is moving like in a zigzag motion because it has resistance with these atoms. So this is called physical term is resistance. It is rho. This letter, this is specific resistance of material. Of particular material. This is the length of the wire. So this would be the length. This would be cross-sectional area. Cross-sectional area. So you see that with it, when the length of the wire increases, the resistance increases because electron has to collide with more of these atoms, and when cross-sectional area increases, the resistance decreases because there is more space for the electron to travel. And units are ohms for this for resistance. Now current, electric current, it is capital I, amount of charge that travels in particular time. So imagine that if through this cross section 10 coulombs of charge travel in 10 seconds, so it would be 1 coulomb per second, or it would be 1 ampere. So this is the units for current, electric current, are coulombs per second or amperes. So this set basically. Now if we have electric circuit, so electric circuit is represented very basic electric circuit. It has voltage supply and it has resistance. This is minus, this is plus terminal. So this is voltage supply. Let's say U is 5 volts. Resistance is 10 ohms. And there is Ohm's law. So basic electric circuit is, this is minus, this is plus, this is voltage source. Voltage source or voltage supply. This is resistor. This can be represented light bulb. Light bulb is similar thing to resistor in many circuits, the same notation. So resistor sometimes is used symbol like this. Americans use this, but basically these are the symbols. So Ohm's law says that current is equal to voltage divided by resistance. This is what you need to know, Ohm's law. And by saying this, it would be equal 5 volts divided by 10 ohms, and it would be 0.5 amperes. So this is the very basic circuit. Very basic circuit. Now electric power. Electric power. So electric power is, what is power? Power P, let's write it P. Electric power P is work divided by time. And the units are work units. Joules, time units, seconds. Joules per second is watt. Watt. How can it be calculated? It can be calculated, power is work divided by time. Work W. Work. What is it? W divided by time, because it's work, or we can write work, not to confuse with watt, so work divided by time. And it can be calculated U times I, because U is joules per second, I is coulombs per second. Joules per coulomb, sorry, what I'm writing. Joules per coulomb. So we cancel this out and we get joules per second. That is the power. Joules per second are watts. We can also write like this. We can write that work is power times time from this equation. And we can write that power is U times I times T. So P here is U times I. So work is U times I times T. So this is electric power. So why it is important, this electric power? Because this electric work is can be turned to various things. Electric work. So electric work A is P times T, or is equal to U times I times T, can be turned to what? This electric work. That electron, remember, electron was traveling in electric field of the battery, and it was producing work. I said it can push something, but when it can push something, it usually pushes these things, pushes these atoms, collides with these atoms, so it can push these atoms. So because these atoms, it collides with these atoms and they vibrate, it generates heat. So electron moving in electric field of battery, produced by battery, does work and hits atoms. These vibrate, and kinetic energy is dissipated as heat. So work can turn to heat. Another thing that work can be turned in is light in electric bulb. So the same kinetic energy is converted to light of this collision. Kinetic energy of electrons is converted to light during electron and atom collision. Also, this can be turned to mechanical energy. In electric motor. We will be talking about this because we will need to a bit more understanding, a little bit more knowledge to know how this is done, how it is turned to mechanical energy. Now, from the equation of P is equal to U times I. So we can write, according to Ohm's law, I is U divided by R. So we can write that U times I. I is what? U divided by R. We can write U squared divided by R. Or we can write that from this equation again, that U is I times R. And we can rewrite this equation. How? P is I times R times I, and it would be I squared R. So this was I, and this was I, so I came here. This was U. U was here, so it came here. So U was here. So these are two formulations, that power is U times I. It can be written as U squared divided by R, or it can be written as I squared times R. Power. From this we know what? From this we know just two formulations, yes? So I wanted to tell you because this is what usually given. Now, what else I want to tell you is that there are two forms to there are two forms of current: direct and alternating current. So this one, first one, it is DC, second one is AC, direct current and alternating current, alternating current. So direct current, direction does not change. Here direction changes. This is time, this is current. So here current is constant. I is U divided by R. And the very basic circuit for this, to obtain this, is just like simple circuit, very simple circuit. And this is produced, DC is produced by constant by source or supply by source of constant voltage, like this. Because it's just I divided by R, so nothing changes, and this would be battery, simply battery. So on DC, laptops operate, cell phones, what else? Computers operate on DC. Batteries, remote control operates on DC. Now here, alternating current. In alternating current, direction changes. So in time, so if we have 0 here, so alternating current is like this. So alternating current is like this. Oscillation. So oscillation, as we were analyzing oscillations. So here, direction changes. Direction changes. It goes to the direction is positive, direction is negative, and this has, as you see, it is sinusoidal oscillation, as we were analyzing vibration. So this has this current has frequency. In Lithuania, I don't know, maybe in Europe it is 50 hertz. In America, I think it's 60 hertz. So period is 1 divided by frequency, so would be 0.02 seconds. So here it is 0.02 seconds. Here it is 0.04 seconds. This is one oscillation, one period. This is period number 2. Yes. As you see, this is one period. This is another period. Yes, it is oscillating. So the circuit is shown like this, but here I made a mistake. So here it is shown like this, like a period, like this kind of period, like of oscillation here is represented. So this is U, and Ohm's law is written like I independence on T as a function of T, U as a function of T divided by R. And this is produced by alternating voltage source. Okay, what else? Speaking about two things I wanted that I forgot to mention you. Well, one thing I forgot to mention. So I will tell now because I will forget. So this is minus, this is plus terminal, this is ordinate circle. Ohm's law is like this. Imagine what happens if we connect these wires not on the resistance, but if we connect these wires like this, one with another, and we leave this resistance somewhere. there is no resistance. So it means that this is practically zero, because the resistance of a wire is negligible compared to the resistance of the resistor. So this is practically zero. So this is, as R is practically equal to zero, what happens to I? So this I turns to infinity, very high. And this power, I times U, will be infinity times U, and it will be infinite. So it means it will burn. So the wire will burn. How to show flames here, I don't know. But the wire will burn, and it can cause fire. So that's why fuses are used if current increases very high. Then fuse breaks the circuit. So this is the cause, usually cause of fires and burning houses, and this is called short circuit, because the circuit is connected not through the resistance, but connected, it's called shorter way, yes. Now what I wanted to tell you one thing about power distribution. So we will learn next time about how alternating current is produced, generators, electric motor, but it seems that alternating current is produced because it's easier to generate using generator, turbines, and electromagnetic induction. We will learn that, and it is and power is electric current, or electric power, how you want to call it. Electric current is distributed transmitted at high voltage and low current. It is done that because if we want to if we would want to transmit at high currents, then we would need to make wires thick, because when cross section of the wire it's narrow, when this decreases, then resistance increases, and we get a lot of energy losses as heat. So in order to because to make thick wires, it is not cost effective. So in order to avoid these losses of heat and money, power is distributed at high voltage and low current. So if it was reversed case, so then wires would need to be thick, and that is not effective. So when power is at power plant generated, so power at power plant, so then the voltage is increased, and if we have a transmission line, we have here high voltage, and then power is decreased, and low voltage is produced to houses. So here it is usually done in steps, and here it is usually done in steps. So increase to high voltage, from low voltage to high voltage. Low voltage is LV, high voltage, and then to low voltage again by steps. Transformators use this with AC. We will learn about AC So AC is the main factor here, and here it is done by this thing by transformer, step up transformer, and here it is step down transformer. So this thing that I wanted to tell you in this lecture, and we will meet later for the last lecture from electricity and magnetism.